Here in Unit 1, Day 4, we're trying to give you some deeper understanding of something called describe a graph completely. Consider the function that you see on this page right here. It's y equals -2 times the square root of 25 minus x squared plus 8. In the first part here, I'm saying identify at least 5 points where the outputs, which are the y's, are integers. And you'll have to approximate the input of x. Here's a trick that we can use. I just want you to see it this way, that if we just focus on this part right here, doesn't it make sense that maybe to make life easy for ourselves, we could just find values of x that give us a perfect square in that part that I've underlined in blue? Here's the simplest, okay? How about if we just turn that into 0? In other words, I'm just going to take 25 minus x squared. I'm just ignoring all the rest, but I want that part to equal 0. So how do I make that equal to 0? Well, add x squared to both sides, and I get x squared on the right is equal to 25. Well, when is x squared equal to 25? You guys know this. If I take the square root of both sides, and I have to consider the plus and minus because both could work, and take the square root of the right, the square root of x squared is x. And so that makes this plus or minus 5. Okay, so look at that. I just found values of x that give me a desirable result. In other words, we just turned 25 minus x squared into 0. Since that's 0 and the square root of 0, so that turns this part into y equals now -2 times the square root of 0 plus 8. Well, square root of 0 is 0. So 0 times -2, 0. And so y is equal to 8. So look at what we just found. We just found one of the 5 points, and that's y is equal to 8. So y is equal to 8 when x is equal to 5, or when x is equal to -5. There's a single integer point right there, and that's an output of 8 is the integer. Okay, let's try that again. We're going to, let me just work this. We'll just keep on doing it until we get at least 5. So we're still focused on 25 minus x squared. What's the next one? We set it equal to 0. That was the first perfect squared. Now let's try, how about 1? We just said that we want 25 minus x squared to equal 1. Now if that's the case, look at what happens over here. If that's just 1, then we're talking about the square root of 1. That's 1. -2 times 1, -2. -2 plus 8, we're getting a y value of 6. And because of the plus and minus, I'm going to go ahead and anticipate that we are going to write 2 answers. And we have to figure out what is that value of x squared now that does that. So we subtract 1 from both sides, we get 0. And that gives me 24 minus x squared is equal to 0. We have to add x squared to both sides, and we get x squared is equal to 24. Okay, 24 is not a perfect square, but when we take the square root of that, we still have to talk about the plus and minus of it in the way that we're evaluating here. And the square root of x squared gives me x. So the left-hand side, 24, do you see a perfect square in there as a factor? Sure, 4 times 6. But the square root of 4 is 2, so we can reduce this then to say plus or minus 2 root 6. If you need to talk to me about this so that you understand it better, then to reduce or simplify radicals, come talk to me, because that's going to be an important thing to understand. Now what we're talking about here is x now is plus or minus 2 root 6. So I'm just going to call this 2 root 6 here. And I'm going to call this -2 root 6. And we know what those are. Let's come up with another one. We want another perfect square. We've let 25 minus x squared equal 0. we've let 25 minus x squared equal 1. Well, not 2, because that's not a perfect square, and not 3, because that's not a perfect square. Oh, but 4 is a perfect square. So let's do this. We're going to say 25 now minus x squared is equal to 4. And remember, we're looking for perfect squares because when we take the square root of a perfect square, we get an integer. Let's go ahead and subtract 4. And I get 21 minus x squared. And that's going to equal 0. When I add x squared to both sides, I get 21 is equal to x squared. Now, if I take the square root, I get the square root of x squared. That's x. If I take the square root of 21, and I'm considering the plus and minus of it, it doesn't simplify, so we just get plus or minus the square root of 21. But in our heads, we need to know that that is a value between 4 and 5, because 4 times itself gives me 16. That's less than 21. But 5 times itself gives me 25, which is greater than 21. So it's a number then between 4 and 5. That's conceptually what you want to be thinking. But now we've just let 25 minus x squared equal to 4. So 25 minus x squared is equal to 4. Square root of 4 is 2. That turns the negative 2 times 2 into negative 4. And we add that to 8. That becomes 4 now. So we got an integer value output of 4. And I'm going to write that down twice again because inside for the x values, we have to write our x values. This is going to be square root of 21. And this is going to be negative square root of 21. We're going to keep on going. I'm going to get all 5 of these, okay? So we're going to go for the next perfect square. We're going to let 25 minus x squared equal the next perfect square. So we had 4 is a perfect square, 5 is not, 6 is not, 7 is not, 8 is not, but 9 is a perfect square. So we're going to say 25 minus x squared is equal to 9. Because when we take the square root of that, we get 3, right? So let's figure that out. I'm going to subtract 9. And I get 16 minus x squared is equal to 0. And then I add x squared, and I get x squared is equal to 16. When I take the square root of that, how nice. We even get an integer for x because this becomes x. Square root of 16 is 4. So we have plus 4 and minus 4. So when x is 4, we've turned 25 minus x squared into 9. Square root of 9 is 3. 3 times negative 2 is negative 6. Negative 6 plus 8 is 2. So we get actually full integer coefficients here. And that's really nice. And we get negative 4 and 2. So there's 5. Let's do one more. We just let 25 minus x squared equal 9. What's the next perfect square? We're saying 25 minus x squared is equal to, we said 9. So what's next? Not 10, not 11, not 12, not 13, not 14, not 15, but, oh good, we got 16. So 16, because that's a perfect square. And we're going to subtract 16 now. And we get 9 minus x squared is equal to 0. We get 9 minus x squared is equal to 0. And we're going to add x squared. And we get x squared is equal to 9. Oh, I can tell this is going to be really good. So when we take the square root of both sides, we're saying x then is equal to plus or minus 3. How nice. We nailed another set of integer coefficients. We got 3, and we don't know what the output is yet, so we got to do this. We let 25 minus x squared equal 16. So that means then that the square root of 16 is 4, and we got negative 2 times 4. Well, that's negative 8. And negative 8 plus 8, bingo, that's 0. And look at that. Negative 3 gives me a value of 0. Okay, kind of interesting. So here we go. Let's go ahead and use these. We actually can make a table of values here to the left here and call this x's and call this y's. And we have, from those ordered pairs, we can actually list some of these things. So we're going to start with all the way down to -5 for x's. The next one is -2 root 6. The next one is -20 square root of 21. The next one is -4. The next one is -3. And for the fun of it, I'm going to throw in a 0 here because I know that that's going to come out to a nice value. And the reason why, if I let x be 0, then I say 25 minus 0 is 25. Square root of 25 is 5. -2 times 5 is -10. -10 plus 8, 2. Okay, so we got that y value pretty easily. And then we're going up the way that we came down. So we got 3, 4, square root of 21, 2 root 6, and 5. So here's our table, and we can actually plot these values. At -5, we're at 8. At +5, we're at 8. At 2 root 6, we're at 6. At -2 root 6, and I just realized that I shouldn't have marked those negative. At -2 root 6, we're at 6. At -root 21, we're at 4. At root 21, we're at 4. At 4, we're at 2. At 3, we're at 0. At -3, we're at 0. And at -4, we're at 2. Okay, we're going to plot. I'm just going to draw a y-axis somewhere on this graph. And I'm going to draw an x-axis on there, and we're going to draw this graph. And just by plotting the points, I'll plot them in red. 0 gives me, it's not 2, it's -2. So once again, we're going to plot that now, and we're going to put it in the right place, which is at -2. At -3 and +3, my y values are 0. So I can put points at -3, 0 and +3, 0. Now let's go for another easy one. -4 and +4 are at a height of 2. And it's looking kind of parabolic here, which is pretty reasonable. And then square root of 21. We know that that's somewhere between 4 and 5. So we're going to fudge where that is. And we know that we're going to be doing that at a height of 4. So at a height of 4, we're going to say between 4 and 5 like this and like this. And then 2 root 6 is a little bit more than that. So, and it's going to be at a height of 6. So we go up a little bit more, and we're still inside of 5. So our points look like that at 2 root 6 to the right and 2 root 6 to the left. And then we're going to go all the way out to 5 and get as high as 8. So we go up another 2, and we're right at 5. And here we're at -5. Okay, and I think this thing is starting to take some shape here. It looks like a parabola, and we want to describe some things about this parabola. If we can draw it straight. Here, I'll do that a little bit better. There we go. And okay, so this kind of intrigues me a little bit because now I'm going, well, gosh, is it going to go farther than that? Can it go taller than 8? Well, in order to go taller than 8, I would need for this guy to go negative, because negative times negative is a positive, and that's the only way that we're going to get something added to 8. But wait a sec. We can't do a square root of a number and get something negative. So notice what we can't do. And we should just write this down. Can't have x less than -5 or x greater than 5. I hope you see that. because there's no values of y that are going to happen when I put in values of x less than -5. And I want you to try to prove it to yourself. But nothing's going to happen there. This means then that this guy stops right there and has no more values to the left, and this one stops right here and has no more values to the right. So really, we're looking at the entire domain and range plotted here. So let's plot the domain, shall we? Domain is all real numbers of x such that x is greater than and equal to -5. And x is less than and equal to 5. See, that bounds the domain right there from here to here. And there are valid x values all the way from -5 to 5. And that works. Let's talk about the range. Do we get any lower than 2 ever? No. So we're at -2 then is less than or equal to y, because we equaled y when we let x be 0, and we equaled -2 when we let x equal 0. Then we also are less than or equal to, the highest point we reach is a height of 8. And so there's our range. And so we need to know how to plot that. Okay. There's a whole bunch of descriptions right there of interesting points. We have an x-intercept right here of 3, 0. We have another x-intercept of -3, 0. We have a y-intercept right here of 0, -2. And that's a minimum point, by the way. So that's another thing that we can say about it. Okay, that's enough. I'm going to let you go off to your classwork and do your thing.